So we continue with the definitions and all these things, further details of vector space. As stated by, so sometimes the terminology is so complex that we may get confused. So if despite this much discussion, if a question is what is vector space, what will you answer? What is vector space? What is the answer? It's a not subset. बऱ्याचदा म्हणजे थोडंसं त्याला काय लागतं हे म्हणता येईल सम काइंड ऑफ थोडीशी प्रॅक्टिस लागते अदरवाइज एव्हरीथिंग इज नोन बट कांट बी एक्सप्रेस आणि टेक्नॉलॉजी येत नाही असं मी सो अगेन आय रिपीट व्हॉट इज डेफिनेशन What is definition? So it's a listen very carefully again. Don't confuse. What is vector basically? Let the idea be very much clear. What is vector? What is vector? Means it should be so clear that even at any point of time it is asked to you. Suppose that if you are unaware and somebody asks you your name, do you forget? No. You answer instantly. So like that, what is vector? What is vector? Order of numbers. And when we say number, it's a real number. Is it clear? So this is something means I am trying to have a simply. I hope that Strang's lecture have you gone through? Or since mid-sem is much away, you are not going through. So that it is understandable or not. So the problem is, then if it is so, man, Strang is obviously well known. That means in linear algebra, even if you go through the Google search, you will find that his what we can say delivery is most popular. If most popular is like this, then what about the others? That may be a problem. This is because that sometimes this is a subject which does not have an instantaneous impact on something unless you find a very critical application. Therefore, the interest students take in thinking over it on their own is somewhat less. And being mathematical, some words which we are not otherwise familiar with are there. So because of that, such things happen. So, and listen very carefully, I am trying my level best. Vector space is a set of such vectors wherein if U is one vector which belongs to that vector space, V is another vector which belongs to that vector space, then any linear combination, लक्षात लगा, if what is vector space? If U is a vector in that vector space, V is another vector in that vector space, then any linear combination of these two also belongs to that vector space. Then say for example, let me, I would like to simplify to the extent where we'll understand. Whether this definition, या डेफिनेशन मधनं नेमकं आपलं काय, आता बऱ्याचदा असं होतं, u हा एक वेक्टर आहे, v हा दुसरा वेक्टर आहे, v हा दुसरा वेक्टर आहे. पुढं डायमेन्शन कसं आहे, सबस्पेस कसं डेफिनेशन करायचं, पुन्हा एकदा मी परत तीच मूळ व्याख्या वाचतो. त्याच्या ए सेट v, तो बोल्ड लिहित नाही, तो कॅपिटल v नुसता आपण लिहितो. A set V is called as a vector space over real numbers provided that the two operations addition and scalar multiplication satisfy all following axiom statements. Linear combination, if U belongs to that vector space, if U belongs to vector space, V belongs to the vector space, then AU plus BV also belongs to the vector space. Also belongs to the vector space. Now, that is one definition of vector space. Further thing is that when will you say that the vector space is completely described? Vector space is completely described by अगदी सोपं सांगतो की तुम्हाला बऱ्यापैकी कळेल. We presume this 3D space, this room, not necessarily, we go beyond also, this entire 3D space as a vector space. A three-dimensional vector space means we are aware of point, line, plane and volume. So we consider conventional 3D volume as vector space. Then the vector in a 3D vector space is described by an ordered triplet. So U equal to 2, 3, 0 is a vector in given vector space, and V is equal to 1, 1, 1, 1, 0. U is equal to 2, 3, 0. V is equal to 1, 1, 0. Then whether U belongs to this entire volume? Yes. Whether V belongs to this entire volume? Yes. Then a linear combination of these two, what it would be? What is U? U would be a point U 2, 3, 0. 2 means something. This is U. 1, 1, 0. Not, it's not somewhat not to scale. I will draw it. This is U. Now, any linear combination of these two, whether it will be in this given vector space, no, any linear combination of these two will be in the given vector space, obviously that. So if I want to express this I can express as something into this plus something into this, and I can find it out. by some method. However, its contrasts, whether any vector in this given space can be described by a linear combination of these two? No. Why? Because this is 0. If this vector is to be described, then no linear combination of these two will be sufficient. So you need one more vector. You need one more vector to describe that. हे अगदी म्हणलं तर अगदी सोपं आहे, काहीच नाही आहे त्यामध्ये, फक्त ते नीट डेफिनेशन आणि पुढे जसं आपण जाणार तसं त्याच्या आयडियाज क्लिअर पाहिजेत. सो आय नीड अनदर वेक्टर W which I can take as 0, 0, 1. Which I can take as 0, 0, 1. This will be third vector, right? So U belongs to V, U bar belongs to V bar belongs to V, W bar belongs to V. All these three belong to V, and in this space any vector can be said to be their linear combination. This is definition of vector space. And dimension, again, what is dimension of vector space? Can you, rather than going for definition, it will come later, can you tell me what is the dimension of vector space? What would be the, what we can, may not be scientific definition, but common sense definition of dimension of vector space? Right. Minimum number of vectors required, dimension of vector space is minimum number of vectors required such that any other vector can be expressed as linear combination of these vectors. So here for a obviously three-dimensional space, the dimension of vector space is 3. Now, what is subspace? What is subspace? What is subspace? What is subspace? Which is part of vector space in itself. I think he don't know whether either he has gone through this Strand lecture very appropriately, or he might have some acute interest in this field. So listen very carefully. I am trying my level best. This is a 3D space. Then, can you give examples? 3D space includes entire volume. Entire volume. Then, what can be the subspaces of this volume? Planes passing through? मराठीत सांगतो. फक्त वेक्टर स्पेसला वेक्टर स्पेस म्हणूया, नाही तर पुन्हा सदिश संच वगैरे ते अगदीच करणार नाही. हा संपूर्ण व्हॉल्यूम हा एक वेक्टर स्पेस आहे असं गृहीत धरलं. म्हणजे एक ओरिजिन आहे, ए लाईन जॉईनिंग इट इज ॲक्च्युली रे, त्यापासून केंद्र निगेटिव्ह व्हॅल्यू असते. ए रे जॉईनिंग द ओरिजिन अँड एनी गिव्हन पॉइंट इन दिस स्पेस or anything parallel to it. लक्षात आलं ना, anything parallel to it, that would be, we can say, as a vector in this vector space. Now its subspace, meaning of vector space, again it's a set of vectors. It's a set of vectors. We restrict ourselves to 3 dimensions for the time being, because कारण पुन्हा हे बऱ्याचदा आपली विचाराच्या क्षमतेत अडचण आहे. म्हणजे या व्हॉल्यूमचा सबस्पेस काहीतरी आहे म्हटल्यानंतर व्हॉल्यूम कशाचा सबस्पेस आहे हा प्रश्न विचारला तर आपण गडबडून जातो. Let us hope that you become more prepared. Now the question is, we want to have a subspace of it. Subspace of the volume. What should happen? There should be some vectors in that subspace, and the linear combination of, basically by common sense, what should be the dimension of subspace? Again, listen very carefully. I hope that you are listening, even though I do agree that it's not that way interesting where something to happen immediately, but let us hope that it creates an impact which will shape you at a later stage. Do you know that in general, not in this vector, in general, in the set theory, a set is subset of itself. Given set is a subset of itself, right? This is one thing. And there is one more subset. What is that? A null set is subset of any given set. What are you doing? You are watching lectures? Look here. So, null set and that set itself, no doubt by classical definition, are subsets. However, those are called as improper subsets, in the sense that we don't carry much meaning. Means what? When I have a subset, there should be something which is not in the subset but in the set. Some entity must be there which is not in the subset but in the set, right? Then it is called as, and the subset is not a null set, then it is called a proper subset. So like that, the entire volume itself is a subset, or origin itself is a subset. Origin or entire volume is a subset. Entire volume means a line joining origin and any point will span the entire volume, or the origin itself. Two. These are improper subsets. Then what are the proper subsets? So what is the example? A plane or a line, and we presume that it is passing through origin. Parallel planes, we say in vector methodology, parallel thing we take a line. Therefore, we say that and now it is very important, it is not either a plane, vertical plane like this, or horizontal plane like this, or something like it can be any plane. It can be any plane. any plane passing through origin is a proper subset, or any line passing through origin is a proper subset. Any plane or any line passing through origin is a proper subset. Now, so will you agree to this, that for a 3D vector space, XY plane पुस्तकात असं लिहिलेलं असतं, is a vector space. This is a vector space, right? Means it covers XY plane. It covers XY plane. Is a subspace of given vector space. But not necessarily this. You tell me XY means what? You are having complete freedom to have any X or any Y. You are having complete freedom to have any X and any Y. But Z has to be 0. When it is so, it would be, everything would be in XY plane. Everything would be in XY plane. Now, can you tell me another vector space such that it is subspace of 3-dimensional space? Same, then XY0, 0YZ, X0, Z are 3 basic planes. Something else than this. So how will you write this? What this would be? Is it a proper subspace? What will happen? What kind of things it would be? कसं कसं प्लेन असेल हे? x anything x within the subspace. Just try to have कसं येते. So if x is 0, y is 0, z must be 1. x 0, y 0, z 1. So you have this point. This point. x 0, y 1, z 0. What happens? Very good. Just see, sir. You need it's not impossible or difficult, but the only thing is that you need to have some kind of independent thinking. When this was 0, what happens? When this was 0, for any x and any y, for any x and any y, you remain in this xy plane. So this is xy plane, which is a proper subset. Now x, y plus 1. What happens? x 0, y 0. So you are here. x 0, y 1. x 0, y 1, x 0, y 1, z 2. You come here. x1, y 0, where you come. So what I want, I hope that if you are listening me carefully and also trying to think on it, you must visualize something. Is it clear? Only thing is that it is not impossible, but it is not instantaneous. You need to rigorously think for some time. This is one example. The other example what we can have is what this can be. What this can be, and this. So x, y, x plus y. So where do we go? So this one, this one. What I want to convey is you should try to figure out a plane which satisfies this. So it's a subspace. Then what this would be? What this is? What do you visualize from this? what this would be? म्हणजे स्ट्रँग आणि मॅथ काय फरक आहे, तर हे म्हणजे काय प्रत्येकाला लक्षात आलं तरी खूप झालं. एक्स ए एक्स बी एक्स हे काय आहे? एक्स ए एक्स बी एक्स हे काय असेल? एक्स 0 0 काय असेल? एक्स 0 0 वन डायमेन्शनल सबस्पेस कुठली असेल ती? एक्स ॲक्सिस. एक्स ॲक्सिस x 0 0, y and z all are 0. When y and z both are 0, it's x axis. x आता एकदम हे नको, टप्पे टप्पे सगळे अजून घेताना तुम्हाला थोडंसं सोपं हे मुद्दाम दिले. x लक्ष म्हणजे थोडं डोकं चालवा, काही म्हणजे त्यांना काही फार त्रास होणार नाही. एक्स एम एक्स 0 म्हणजे काय असेल? एक्स एम एक्स 0 मी एम मुद्दाम वापरलंय. y equal to mx, what is that? लाईन पासिंग थ्रू ओरिजिन विथ स्लोप m. म्हणजे ही लाईन एक्स पण एक्स वाय झेड 0 आहे, एक्स वाय प्लेन मधली लाईन. This line is a one-dimensional subspace. आणि आता हे केलं तर इथं n शब्द वापरत नाही, म्हणजे काही नंबरचे आहे म्हणून p वापरतो. m x mx px काय असेल? बरं थांबा, अजून एक थोडं टप्प्याटप्प्याने घेऊया. x 0 px काय असेल? लाईन पासिंग थ्रू ओरिजिन विथ स्लोप p बिटवीन z and x. कशी असेल ती? ही अशी होती, आता कशी? अशी. हा z ॲक्सिस आहे, हा x ॲक्सिस आहे. दिस इज द लाईन. अशी होती mx. x mx 0 x 0 px. आणि आता x mx px कशी असेल? ही अशी होती, ही अशी आहे, तर ही अशी होती, ही अशी होती, आता अशी. लक्षात आलं का? x mx px. Same thing you can say that if you divide 1 by m and p by m and call this as y, like this also. Right? So this would be a subspace. Then in subspace again many vectors are there in every subspace. Volume is a vector space. Any plane, volume is a vector space. Volume has got infinite subspaces. Infinite subspaces as planes passing through origin. Infinite planes passing through origin are its infinite subspaces. Like this, like any page you take and pass it through origin. So these are different subspaces. So the vectors in a particular subspace, vectors in a particular subspace need, means they Now, dimension of a plane is 2, dimension of volume is 3, dimension of plane is 2, and dimension of line is 1. So for a line there will be only one basis. For a plane there are the set of vectors, there will be dimension 2, number of vectors in a basis are 2, and for volume the number of vectors in the basis are 3. Now, can you, if we take a plane, this xy plane, a plane 45 degrees like this plane, try to figure out this plane. अच्छा लगा? This plane which is 45 degrees to xy plane and this xz plane. Then the task is construct the basis for the plane shown. Construct the basis for plane shown. दोन वेक्टर असे सांगायचे which will form the basis, such that every vector in the subspace can be described by linear combination of these two. What it would be? प्रश्न लक्षात आला का? 3D वेक्टर स्पेस सगळ्यात सोपा बेसिस कुठला? 3D वेक्टर स्पेसचा 1 0 0 0 1 0 0 0 1. The basis of 3D vector space is 1 0 0 0 1 0 0 0 1. This is the basis. असं नाही पाहिजे अशी लिहिली. XY प्लेनचा बेसिस कसा येईल? सोपा एकदम. 1 0 0 XY प्लेनच्या बेसिस मध्ये किती वेक्टर असणार? 2. 1 0 0 0 1 0. XZ प्लेनच्या बेसिस मध्ये 1 0 0 0 0 1. आणि YZ प्लेनच्या बेसिस मध्ये 0 1 0 0 0 1. आता ह्या प्लेनच्या बेसिस मध्ये किती असतील वेक्टर्स? लक्षात ना, एकदम सोपे, अवघड काहीच नाही आहे. असे दोन वेक्टर्स की यातला कुठलाही वेक्टर त्यांच्या लिनियर कॉम्बिनेशननं एक्सप्रेस झाला पाहिजे. A plane which is making an angle of 45 degrees to XY plane and XZ plane. One zero zero and this plane 0 1 1. So what he says, 1 0 0 and 0 1 1. म्हणजे काय झालं पाहिजे? ओरिजिन घ्यायचं, हे प्लेन ओरिजिन पासून ह्या प्लेन मध्ये कुठेही आलो हे जे प्लेन आहे असं ओरिजिन पासून या 45 डिग्री प्लेन मध्ये हा असेल, हा पण असेल, हा पण आहे, स्वतः पण आहे हा, कारण इथं प्लेन x axis is a part of the plane as he rightly mentioned. x axis is a part of the plane. त्यामुळं तिथं कुठे मिळू शकतो, असा असू शकतो, असा ते असा, असा हा 45 असा असा, म्हणजे y आणि z जे आहेत एकदम सोपं आहे. म्हणजे एक्स ऍक्सिस तर प्लेनचा पार्ट आहे आणि मी असं चाललोय, मी ह्या दिशेने चाललोय. कसा चाललोय, मी एक्स ऍक्सिस कुठेही असेल ते मटेरियल आहे, पण मी